we're going to see how to query min and max elements in an array in O1 time or constant time. For this, let's take an example of an array and give some random numbers that are present in the array. Okay, for this we would need one queue and two tqs or double-ended queues, one for min and one for max, one for finding min and one for finding max. Okay, cool. So now how do we implement this? So let's say the queue is this and tq min is something like this and max is this. Okay, so let's enqueue the first value, that is true. So always if you enqueue, you always add it to the queue, this one, always add it. And if the dq min or dq max are empty, you just push, you don't do anything, you just push the element. Now let's go to the second element, 7. So when you encounter 7, you just push, and for min you just check if the element in the back is lesser than the element that is coming inside or the element that is about to be inserted. In this case it is true for min, so you just push. And for max, you have to see if the back element is greater than the incoming element. If you see here, 2 is not greater than 7, hence you just pop out until you find a number which is greater than the number that is going to be inserted, right? Or the queue has to be empty. If the queue is empty, then automatically you have to push the number inside. There's no other number left. So in this case we have the queue empty, so we just push in 7. Cool. Now we'll go to the next element, which is 1. Insert into the queue, and dq min, we see the back side, the element at the back, and we find the element to be greater than the element that's coming in. So what do? You pop. Again, the element is greater than 1, so we just pop. Now the queue has become empty, you push 1. Okay, done. Now is the element at the back greater than 1? Yes, so just push, don't do anything. Go to 5. Now push 5 because 1 is lesser than 5. Here you can pop 1 and 5 because it is lesser, the back element is lesser than what's coming inside, and that's max queue. You have to maintain max elements in the ascending order from front to back. Now 10 comes in, you see the back side. Okay, 10 seems greater than the back side, just push 10. Here the element in the back is not greater than 10, pop 5, pop 7, push 10. So this is all. So now if you want to find the min or max elements at a particular point in time, so we have inserted all these elements. Okay, now among these elements we can find the min or max. So if you query min, always return the front element in the dqs. So min would be the front element of dq min, which is 1, and max element would be the front element of dq max, which is 10. Okay, what happens if we only have, say we eliminate 2 and only consider from 7 to 10. So let's say we dq 2. So what you do is the dq step, if the element that you're dequeuing and the front matches, pop from both, or else just leave it. So you're going to pop 2. Does the friend match 2? No. Does the friend match 2? No. In both min and max, the friend doesn't match. So you just pop from here and don't touch dq min and dq max. So even if you remove 2, if you consider this part of the array, the min is 1 and the max is 10, right? There's no harm. There's no changes. So that is all. So let's say what happens if you just consider this one, right? So you have to pop or 7 and 1. So when you pop 7, nothing happens because the friend doesn't match 7, the friend of dq max doesn't match 7. But when 1 comes, the friend of dq.min matches 1, so you pop both. Max, it doesn't change. So now when you consider only this part of the array, you have the min as 5 and max is 10. So this is how we can find the min and max in O time using Q and DQs. Thank you.